Okay, hello everyone. Guys, we're going to look at day 12 assignments here. We're just going to do two of them. I'm going to save the exit ticket for you guys. Guys, this note sheet I opened up in a separate tab, and it's right here. Guys, it just reviews types of numbers. This warm-up, we're just going to talk about the different types of solutions that a quadratic could have. Of course, guys, an integer is a whole number. All right, like a negative number, or it could be 0. A whole number or a negative, all right, like -4 or 7, it's a whole number, okay? A rational number, it could be an integer is also a rational number, all right? A rational number is any number that can be expressed as a fraction of integers. An integer itself can be expressed as a fraction of integers, like 7/1, okay? But anything that can be expressed as a fraction of integers, that's rational. Irrational, they're real numbers, but they cannot be expressed as a fraction of integers. They can't. All right, as an example, these square roots that aren't perfect squares, the square root of 2, the square root of 137, they're not perfect squares. Even a number like this, all right, 1 plus the square root of 5/2, that number right there is irrational because there's a square root of 5 in there. And we know pi is irrational as well. It cannot be expressed as a fraction of integers. Guys, complex numbers are non-real numbers. We've talked about them a little bit. When the graph is above the x-axis and never touches the x-axis. Guys, we use complex numbers when we want to take the square root of a negative number. And we'll do that when you guys get to your junior year. Again, if it's the square root of a negative number, all right, then it's considered a complex or a non-real number, okay? Now let's go back. We'll start with the warm-up. Let's go ahead and do it. Call it out. All right, guys, the proper type of solution to this quadratic equation. Well, this is factorable. It's in factored form. The solution is 1 or 5. 1 or 5. Those are rational. All right? And the same thing here. The solution here, it's -2/3 or +1/5. Those are rational. That's rational. They're fractions of integers. All right, this one here, this is factorable. Again, 15 is 5 times 3. And 5 minus 3 is 2. All right, our answer is going to be 5 or 3 or -5 or -3. They're rational. That's factorable. Rational. All right, this one right here, it's rational, okay? If I add 25 to both sides and then take the square root, the answer here is 5 or -5. 5 or -5. That's rational. All right, this one's different. If I add 5 to both sides and take the square root, I'm looking at the square root of 5 plus or minus the square root of 5. That is irrational. The square root of 5 is irrational. And let's back to this last one. See, the square root of 25 is rational. It's 5. All right, 25 is a perfect square. Back to number 5, but 5 is not a perfect square. So it's irrational. All right, now this one says +5. So if I move it to the other side, it's -5. So I'm trying to take the square root of a negative number. That is a complex number. It's a complex solution to this. I need to take the square root of a negative number to find the answer. All right, this one says +25. If I move it to the other side, it's -25. And even though 25 is a perfect square, I still am trying to take the square root of a negative number. It's complex. It's a non-real number. The solution is non-real. All right, plus 17. If I move it to the other side, it's positive 17. Then I take the square root of 17. The square root of 17. 17 is not a perfect square. That's an irrational. All right, 16 is different though. If I move it to the other side, I have positive 16. And the square root of 16 is 4. It's a perfect square. It's rational. That one's rational. All right, the square root of 16 is 4. So 16 is a perfect square. Unlike number 8, let's back up. 17 is not a perfect square. If I take the square root, I end up with the irrational number. Where 16 is a perfect square, I take the square root, I end up with 4. All right, number 10. The solution to this quadratic is above the x-axis. It never touches the x-axis. This has a complex or a non-real solution. Okay? 11, this is the parent function, y equals x squared. The solution is 0. 0 is a rational number. All right? Go ahead and submit that. All right, guys, we're going to go for the worksheet. I'm going to put it underneath the document cam here. And we'll look right at it, guys, all right? Guys, we're solving by completing the square. And frankly, guys, you solve it however way you want. Just show work. All right? Again, how do you do this? You add 90 to both sides. So I put 90 on this side. I leave a little space here. So what I do is I have to add. Half of 20 is 10. 10 squared is 100. So I add 100 to both sides. Why do I do that? Because now I can write this as a perfect square. And 90 plus 100 is 190. I take the square root of both sides. Again, this side is just now x plus 10. But this side has to go plus or minus the square root of whatever's over there. So now I just subtract 10 from both sides. Put the 10 over here, so it's negative 10. Plus or minus the square root of 90. That's the answer. Remember, guys, half of b squared is how you complete the square. All right. All right. B, or number 2. Again, b squared is okay in front. So I take the 90 to the other side. It's positive. Half of 12 is 6, and 6 squared is 36. So I add 36 to both sides. All right, so I can write it now like this. X plus 6 squared, and the side is 126. Take the square root of both sides. All right, 126 is actually 9 times 14. So the square root of 9 is 3. I can simplify it. Take the 6 to the other side. It's now negative. Plus or minus 3 times the square root of 14. All right, number 3. Again, a little more difficult. Again, m squared in front is good. There's no a is 1. So I take the 36 to the other side. Half of 9 is 9 over 2. 9 over 2 squared is 81 over 4. So I added that to both sides. So now I can write this side like this. M plus 9 over 2 squared. And this side I combine them together. 56 and a quarter, which is 225 over 4. That's what I got there, okay? The reason I did that is because now I can write like a perfect square, all right? When I take the square root of both sides, that's a perfect square. It's 15 over 2, plus or minus. All right, so then I just subtract 9 over 2 from both sides. So negative 9 over 2 plus 15 over 2, and negative 9 over 2 minus 15 over 2. I got 2 answers, 3 and negative 12. Right. Guys, I have to stop here. I'm running out of time. I'm going to show you the rest of these quick. All right? I'm sorry, but I'm running out of time, guys. You can stop and take a look at using this like a key. Okay, I'm just about to hit the limit right now. Guys, I'm going to quickly look over. I'm sorry about that. Guys, the exit ticket, you're going to have to do it on your own. You can do it, okay? All right, that's it. Thanks.